Lesson 8.5, page 547. We're doing notes on graphing quadratic functions. Okay, first of all, let's look at what a quadratic function is. So, function, so we obviously have f of x. Remember, that's the same as y, okay? So, then they give you the rest of it. Standard form tells you that it is ax squared plus bx plus c. That's where we get AC method from. So that's where you will start, okay? This is the form. Anything with a squared right here will be a quadratic function. That means that it will be a parabola, okay? This is a parabola. Parabola. It's a nasty mathematical disease that is spread across the country. Okay, parabola. You need to know that if A is positive, then the parabola is opening up. If it is negative, then the parabola is opening down. Okay? So if you want to make a little chart or write that in words, whatever you want to do, you can. Okay? The point is that if it's negative, it goes down. If it's positive, it goes up. Okay? Now, there's some vocabulary that you need to know other than parabola. If you see a parabola, every parabola has an axis of symmetry. Okay? The axis of symmetry is basically where it can be reflected. So I'm going to draw this dotted line. As awful as that looks right now. This would be the line where if I folded my paper in half, then the lines would meet up. Okay? In a perfect world where I could draw parabolas the correct way, that's what would happen. It's supposed to be straight. Okay, this is the axis of symmetry. Write it in. S-Y-M-M-E-T-R-Y. Hold on, Casey. Symmetry's coming up. Now, the axis of symmetry will always come in this formula. You're going to need this. X equals negative b over 2a. And this b comes from the standard form. And the a also comes from the standard form. Okay? I'm just going back and forth so you can see it. But that is the formula you will find for your axis of symmetry. It'll be always x equals something. What am I holding on for, dude? I'm not moving. This is a... My sixes look very specific. Okay, so since Bree can't tell the difference between a 5 and an S.
Yesterday you told me. Moving on, I got things to do.
Yeah, you would think. Okay, flip the page. We're going to start with an easy example. Flip it one more time. Here's, I don't know what number this is. I'm just going to tell you to write it down. Negative x squared plus 8x minus 12. Okay? I am not sure. Okay, so I just want to do an exercise on finding the axis of symmetry. So x equals negative b, so I'm going to keep the negative out here. I'm going to identify my b. My b is 8 over 2 times a. So a here is what? Negative 1, right? So it would be a negative 2 when I multiply them together. When I reduce this, I will get negative and negative makes positive. 8 divided by 2 makes 4. So the equation for the axis of symmetry is x equals 4. Okay? This will help you in your graphing, because it tells you where the center of your parabola will be. Any questions on that before we move on? Right, what is a coordinate pair here? This is an equation. So this is x equals 4, the equation of the axis of symmetry. So we're going to graph this, so hopefully I'll better explain. If I don't answer your question, Reagan, go ahead and ask it again. Okay, so for my sake, I'm going to write this as example 1 so that I have some annotation on my graphing paper here. Create a set of x and y axes. And I'm going to draw my line, my axis of symmetry at x equals 4. So I go over 1, 2, 3, 4, right there. I'm going to draw an axis of symmetry. It's just going to be a dotted line, not a solid line. Okay? Maybe I should have done that in different colors so we can see it a little better. Okay, the axis of symmetry, I think that helped out a little, will identify our x value for our vertex. Okay, so our vertex will be an x comma y, obviously. Okay, we already know that our x is going to be 4. It says so in this equation. So I'll plug in 4 for my x, and I need to find y. I can find my y by simply plugging into this equation. Okay, so since x is 4, it's going to be negative 4 squared plus 8 multiplied by 4 minus 12 will give me my y, or f of x, right? All I'm doing is plugging in. This one right here is in standard form, yes. So all I'm doing is plugging in x. So x is 4, so I'll plug it in and solve for it. So I get 4 squared, which is 16. So I have a negative 16 plus 8 times 4 is 12 minus 12. So those cancel out. It's going to be a negative 16.
Why did you add 4? That would be 32.
You're right. So that doesn't go away. It turns into a 20. 20 minus 16 is 4, right? Did I mess up anything else? Okay, thank you. So the coordinate of my vertex is 4, 4. Okay, so now I've done 2 things. So maybe you might want to write this. 1, find axis, right? 2, find vertex. Okay, so I found my axis, I drew that line. I found my vertex, it's at 4, 4, so I'm going to go ahead and graph that. 4 over and 4 up puts my axis of symmetry right on the line there. Okay, so my axis of symmetry creates a line that will basically flip, and it will allow me to find the y so that I can find my vertex. So I've graphed those 2 things. Next piece, it's literally plotting a point, guys. So when you get to this, it's not, oh my gosh, how hard is this going to be, kind of a deal. All I have to do is ask myself, is it opening up or down? So here's the question 3, up or down? So obviously this one's going to be opening down, right? Because it's negative. So on this one in particular, we're going to go with down. So we know it's going to be opening downwards. And then I always just choose one to the right or left. If you want to choose a different one, that is fine by me. The reason I do that is because this typically keeps me on my graph. Makes it really easy to do. So I pick one to my left or to my right. It doesn't matter which, because my axis of symmetry is going to make it fold. I'm going to say, let's do 3. Okay, so I'm picking one point to the left. I'm picking an x that's to the left. I'm going to pick 3. So I plug it into my equation. Negative 3 squared plus 8 multiplied by 3 minus 12. 3 times 3 is 9, so I get a negative 9 plus 24 minus 12. And I finish solving. I have a negative 9 and a 24, which will make a positive 15. 15 minus 12 will give me 3. Okay, so I plotted an x of 3, and I found a y that is also 3, and I plot that point. 3, 3, 3, 3, lamb, there it is. What the axis of symmetry allows you to do is not have to find this second point. You need 3 points. What the axis of symmetry allows you to do is just to reflect it on the other side. Okay? If I plugged in 5, I would get the exact same answer. Okay? So I'll show you here in a second, but after I create these 3 points, I just make it with a parabolic shape. There we go. That was better. Second time around. Okay? I just connect it with a parabolic shape. In your computer where they're making you do this, they will make you find the axis of symmetry and 1 point. That's it. Okay? Once you find your axis of symmetry, your vertex acts as your first point, and the second one over here will act as your point that makes it reflect. Okay? If you get confused on your computer and how it wants you to write it, just call me over there. It is a little weird. Okay? So up or down, and then plot a point of your choosing to the left or right. And then lastly, reflect that point. Reflect that point, and then you basically just connect the dots.
So you decided if it was up or down
Because I need to know which direction my parabola is going to open. I mean, it'll be fairly obvious when I find that second point. If it's lower, it's going to open down. If it's higher, it's going to open up. Because when I connect it, it's just natural to do that. And number 6 is just connect the dots, graph it, right? Questions before I remove this? That's not really a question. More of a statement. Let me know when you're ready. Okay, we're going to go to example 2. Anybody else still need it? Okay, example 2 gives us this equation. F of x, or y, depending on what you're more comfortable with, is 2x squared plus 6x plus 5. Okay, so already looking at this, I can tell that my graph is going to be a parabola because of this squared. And I know it's going to be opening, which way? Up, because it's positive, right? So I'm going to follow the same exact steps. Example 2 on my paper. Okay, I need to find my axis of symmetry. So x equals negative b, which is 6, over 2a, which is 4. And I reduce this if I can, which I can. 3 halves, right? Or negative 1.5. Now this axis of symmetry is going to be a little different because it's a half unit, right? So at 1.5, it's going to be approximately right there on my graph. I still have to draw that dotted line for my axis of symmetry here. Okay? So I have one piece down. I have the axis of symmetry. I went way too far down on that line. Anyways, so I have the x. X is 1.5 and it's negative. Okay? So there's my axis of symmetry. Step 1 covered. Next, I need to find the second point to identify my vertex, right? So I plug in 1.5. So 2 multiplied by 1.5 squared plus 6 multiplied by 1.5 plus 5. What is 1.5 squared? 2.25? Yes. Thank you. Say it again.
2.25.
2.25 multiplied by 2 gives us 4.5 plus negative 1.5 multiplied by 6, which will give us a negative number, 9. Negative 9 plus 5. Okay, start solving this. 4.5 minus 9 gives us a negative 4.5, plus 5 will give us a 0.5. So the coordinate for my vertex is going to be negative 1.5, comma, 0.5. Close parentheses. I have to graph that. So I go over to negative 1.5, and I did not do that. I am on a roll today, guys. Negative 1.5. There's my axis of symmetry. I need to find negative 1.5 comma 0.5. Negative 1.5 comma 0.5 is approximately right here. Son of a gun. 5th time. Guys, we're having a heck of a day today. This is why we don't do work in pen, guys. Negative 1.5, positive 0.5 is right here. Am I good now?
Yes.
Awesome. Somebody's got to keep me in check, I guess. Next, I choose a point to the left or to the right. And for the sake of me not screwing this up again, I'm going to choose 0. Okay? 0 is slightly farther than 1 unit to the right, but it ought to give me a decent little number to deal with. So I'm going to go 2 times 0 squared plus 6 times 0 plus 5. It's going to give me 5, right? Thank goodness. 1, 2, 3, 4, 5. Blam. I plot that point, and I reflect it on the other side. So since this is 1.5 units away from the axis of symmetry, it's going to be 1.5 units on the other side as well. Okay? We already knew it was opening up. I now just connect the dots. Questions other than all those screw-ups? Okay. Preferably one without quite as many mess-ups. Alright, the ones that you're going to see on 8.5 that are probably going to confuse you are maximum and minimum problems. So, on examples, I think 3 through something. Let's just do example 3, okay? It'll give you this equation a lot, so I want you to see it. This is a function of t. It is where the active gravity, which is negative 16, okay? T squared, that's time squared, plus 52t plus 3, okay? You're going to see this part a lot, this negative 16 times time squared. That's the active gravity on anything that's basically not in a vacuum here. Or actually in a vacuum. Active gravity in a vacuum. Okay, there's nothing else acting upon this. The question asks us to find the maximum height attained by a baseball, find the time it takes for the baseball to reach its maximum height, and then find the time that it takes the baseball to strike the ground. Okay, there's 2 spots. If we drew this out, I'm going to draw this on my junk paper here. It's negative 16t. So which way is this opening?
Down.
Down, right? So I'm going to run a pretend here. If this is what our graph looked like, okay, he threw the baseball. When is it going to hit the ground? X is the ground, guys.
5.5.
Approximately right here, right? If my graph is correct, that's where it would hit the ground. Where what she's saying is 5.5. This is just a rough sketch, okay? I just want to identify what it's talking about in the question, so when we get there we know what we're talking about. When it says when does it hit the ground, it's asking what is time, t, when we're at 0, okay? Alright, let's identify the first part of the question. It says maximum height. So if I was going to plug this in my calculator, it'd be really easy. I just go in there, plug it into my calculator, press maximum, answer the questions, and it would tell me. What we are doing is we're going to use this equation because it's actually faster to do it that way. You take x equals negative b, so negative 52, divided by 2a, so negative 32. And then I find out whatever that answer is. Okay? 52 divided by 32.
13.3.
Give me a decimal.
1.625.
1.625. And it's positive because there's two negatives, right? So x would technically be time here because our x-axis is t. Okay? That's what we're inputting. So our time, when it is at its maximum height, is 1.625. Okay? This equation takes a lot less time than plugging all that stuff in your calculator. So, to answer the first question, or second question, I think, find the time it takes for the baseball to reach its maximum height. The time is 1.625, and time is in seconds. So, part B, we have to go A, B, and C. Part B is 1.625 seconds. Okay? Next, find the maximum height attained by the baseball. Well, the height would be the y part of this. So I could take 1.625, plug it into my equation, negative 16 multiplied by 1.625 squared plus 52 multiplied by 1.625 plus 3. Now this one might be a little easier just to shove into your calculator and find it. Okay? 1.625 squared times 16, negative 16, negative 42.25 plus 52 times 1.625 plus 3. 84.5. Okay, now I need to add this up. 42.25 plus 84.5 should give us a 42.25. Is that right? Somebody check me. Judging from my past failures. 42.25 plus 3 is going to be 45.25. So again, I'd go back to make sure that my units are correct, but this will be the maximum height that is attained by the ball at time 1.625. Okay, so this is in feet, not very high. So 45.25 feet would be the answer to A. Then the last question says find the time it takes for the ball to hit the ground. So looking back at my equation here, what is happening when the ball hits the ground? Crosses the x-axis. It's called the x-intercept. So when the x-intercept, what is 0? Y is 0, right? So I would basically be solving this equation for when y is 0. So I'd go 0 equals negative 16t squared plus 52t plus 3, which we just learned how to solve these, quote-unquote learned. We've been doing this for a little bit, right? So we'd use the AC method if we couldn't pull anything out of this. Can I pull anything out of it? No. What do I need to pull out of it in order to solve this, though? The negative, right? So I'm going to go ahead and do that. I'm going to divide by a negative 1. When I divide everything by a negative 1, I get 0 divided by negative 1, which is 0. I get negative 16 divided by that gives you positive. This one gives you a negative. And this one's a negative. Okay, now I can start to solve. I'm going to solve this by using the AC method. 16 times 3 is 48, right? It's negative 48, so I'm looking for difference. I need... That's a tough one. Well, I'm about to introduce you to the quadratic formula, I think. I am indeed about to introduce you to the quadratic formula. Okay, you need this. Here we go, quadratic formula. Put this down on a note card, unless you just want to be a weirdo and be forced to memorize it like I was. It's negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Especially if you're going to be taking 110. You need this equation. Okay? If any of you are going into fields of medicine, engineering, anything that is mathematics related, you will need this. Okay? Like 90% sure that education majors have to do this. I'm not 100% on that, but anyways, here we go. This is something that you are going to be heavy in college algebra, okay? You use this a lot. Ask Jamie. Actually, don't ask Jamie. Ask Sarah.
Why not ask Jamie?
Okay? This equation is based off of our standard equation. So B is the second term, A is the first term, C is the last term, okay? So that is what it's based off of. I'm going to use these numbers from our equation to plug into this formula. So negative, it'll turn into a positive if it's a negative, yes. I just want to reillustrate the axis of symmetry. That's the first part of this equation. Negative b over 2a, look, negative b over 2a. That's where that comes from. Okay, it comes from the quadratic formula. All right, so we're going to start pulling this. Negative b, which is negative 52, plus or minus, that comes into key a lot here in a little bit. B squared, so b squared is 52 squared. Somebody tell me that number, please. 2704. Okay, minus 4 multiplied by a, so 4 multiplied by negative 16, multiplied by c, which is 3. Okay, so this will change our equation a little bit on that side of things.
Negative 192.
Negative 192. So we have a negative and a negative, which makes a positive 192. I'm going to rewrite that here in a second. All over 2a, so that's a negative 32, because 2a, right? This plus or minus means I'm going to end up with two equations. Okay? Negative 52 plus the square root of 2704 plus 192. Tell me what 2704 plus 192 is, please. It is 2896. Why did I write an 8? 2896. Okay, over negative 32. Then the second equation will be negative 52 minus the square root of 2896 over negative 32. And I'll solve both of these. Okay, so go ahead and do that. Do it in your calculator so you know how to do it. That square root is the tricky part, so make sure that you close your parenthesis on it. Your first one should be around negative 0.06. Second one should be 3.31. If you did not get that, raise your hand so I can come help you on your calculator. Okay, going back to my graph here, this is, I'm going to be playing pretend here, okay? If this was the negative 0.06 and this is the positive 3.31, which one am I talking about?
Positive.
I'm obviously talking about the one that's positive, right? We're talking real time here. So how long does it take the ball to hit the ground? 3.31 seconds. So to answer my last question, approximately 3.31 seconds. Cool. That formula is a tricky one if you are not diligent. Be very, very careful when using it.